Assalamu alaikum. Today we will learn how to find out the components of a vector. Previously, we know that how to write down the rectangular components, that is column vector of a vector. This one is a vector. To find the column vectors, we will stand at the tail, move horizontally towards the head, this one, and then we will move vertically towards the head. These are the rectangular components of this vector A. Now the green line shows the horizontal component and the vertical line shows the uh, blue line shows the vertical component. If this length is 3 and this blue length is 1, then we can write down A in terms of column vectors. Three is the horizontal component and 1 is the vertical component. So we know the method how to write down the rectangular components of a vector, or how to write down a vector in terms of a column vector. Now we will learn more about the components of a vector. These components are at an angle of 90° with each other. I will elaborate this concept with the help of an example. This one is a quadrilateral A, B, C and D. This point is E, this point is F. Now I want to move from A to C. What may be the possible path for the journey from A to C? One option is I will move from A to B, then I will move from B to C. There are many possible paths from A to C. One is A to B, then B to F, then F to C. Other options are maybe AC is equal to A to F and then from F to C. AC may be A to D plus D to E plus E to F plus F to C. These are all the components of AC. These are all the ingredients of AC. These are all the components of AC. The components of AC may be AB plus BC, may be AB plus BF plus FC, may be AF plus FC, may be AD plus DE plus EF plus FC. It is possible that the components may be A to F, F to E, E to C. Now the method of writing the components is in AC, A is the tail and C is the head. Now, how to write down the components? Stand at the tail, move towards the head, add all the vectors in the subsequent motion. This one is the method to write down the components of any vector. Now I will elaborate this concept with the help of examples. Now question number 3. Exercise 3D question number 4. In the diagram PQRS, P, Q, R and S is a parallelogram. M is the midpoint of P and Q, and N is on SR such that SR is equal to 3SN. First of all, we will deal with this ratio. We will convert this one into a fraction. SR over SN is equal to 3 over 1. It means SR is 3 portions and SN is 1 portion. SN is 1 portion and SR is 3 portion. So NR is 2 portions. To SR, we have divided SR into 3 portions in which SN is 1 portion. So NR is 2 portions. Now, how can we find out SN? Suppose that SR is 10. How can we find out SN? SN is equal to ratio over sum of ratios, that is 1 plus 2 into total, which is 10. Ratio over sum of ratios into total. If you want to find out NR, then ratio over sum of ratios into total. In this way, we can find out Sn and Nr. Now, given that PS is equal to A, this PS is equal to A, this one is a parallelogram. If PS is equal to A, QR is parallel and equal to PS. So QR is also equal to A. PM is 2B, M is the midpoint. So MQ is also 2B. Total PQ is equal to 4B. Now express in terms of A and B, MR. Now the first part is find out MR. We will write down the components of MR. The method of writing the components is the method of writing the components is stand at the tail, move towards head, and add all the vectors in the subsequent motion. Now in MR, M is the tail and R is the head. We will stand at the tail. This one is the tail. We want to approach towards R. Now, first of all, I will move along MQ and then from Q to R, which is my R is my destination and M is the starting point. Now the components of MR are MQ plus QR. MQ is equal to 2B. And QR is equal to A. So the final expression of MR in terms of AB is A plus 2B. Now we want to find out Rn, the B part, Rn. Now we will use the this ratio method to find out Rn. We know that SPQ is equal to 4B. So SR is also equal to 4B. Now we want to find out Rn. Rn. What is the expression for Rs? The direction should be same. If I want to find out Rn, then I should have the vector Rs. Now Rs is minus 4B. Now Rn is equal to ratio over sum of ratios into total. What is total? Total is Rs. 2/3 into minus 4B, and which is equivalent to minus 8/3B. Now the direction of Rn and Rs should be same. That's why I have converted SR into Rs. Now this one is the answer to part number B. Now the C part is find out NM. NM. C part is we want to find out nm. First of all, I will write down nm in terms of components. I will stand at the tail. Tail is n, head is m, and move towards head, and will add all the vectors in the subsequent motion. Now I will stand at the tail n. I will adopt the path nr because I have this vector rn. Now I will use the path rm because part number A I have mr. Now the components of nm are nr plus rm. I have the value for rn. When I will reverse this direction, that is when I will convert this one into nr, I will have to put a negative sign with the expression. Rn has the expression minus 8 over 3b. nr will have the expression 8 over 3b. I will change the sign. 8 over 3b. Rm. Now I want to write down the expression for Rm. Rm is, I have Mr. Mr is A plus 2b. Rm will be minus A minus 2b. Eight over 3b minus 2b plus 2 over 3b minus A. I will add these two. This one and this one. The answer should be a simplified expression. 8 over 3b minus 2, 2 over 3b minus A. So the answer for nm is minus A plus 2 over 3b. Now I will give more examples to elaborate this concept. We can also find out nm, the C part, in this way. nm is equal to nr plus rq plus qm. But this one is a lengthy approach. nr is 8 over 3b. rq is minus A rq. The expression for qr is A, so the expression for rq should be minus A. Now the expression for mq is 2b, expression for qm should be minus 2b. We can also find out nm in this way. This one is again A plus 2/3 p. Always underline the vector quantities. Now, question number 9. In the diagram, the in the diagram, D is the point of intersection of the diagonals of the quadrilateral PQRS. There is a quadrilateral PQRS. D is the point of intersection of the diagonals PR and QS. PR is equal to 3PT. First of all, we will deal with this ratio. We will convert this one into fraction. PR over PT is equal to 3/1. PR is 3 portions, then PT is 1. PR in total is 3 portions and PT is 1. 1. So PR is 2 portions. PS is 5P. PS. PS is this. This one is 5P. Five B. PQ is PQ is PQ is 4A plus P. And PR is PR is 3A plus 12B. PR is 3A plus 12B. This PR, the direction should be this, is equal to 3A plus 12B. This PR. Now, part number A is find out RS. 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 First of all, we will write down the components. We will stand at the tail. In this one, tail is R. And then we will move towards S. RP plus PS. RP plus PS. Here we have PR, which is 3A plus 12B. So RP is minus 3A minus 12B. And PS is given 5A, 5B plus 5B. The final answer is 3A minus 7B. Now this one is the expression for RS. Now part B. Part B is we want to find out RT. RT. The ratio of RT and RP is given, that is 2, 1. We want to find out RT. RT is two portions. So ratio over sum of ratio is 2 plus 1, 3 into the total is given, that is 3A plus 12B. But the direction of this vector should be the same as the direction of RT. So here we will use RP as the total vector. RP. Now the expression for RP is minus 3A plus minus 12B. Because we have changed the direction of PR. And the final answer is minus 2A minus 8B. This one is part A, 1. This one is part A, 2. Now we want to attempt part A, 3. We want to find out RQ, in which R is the tail and Q is the head. I will stand at R and then move in this direction, R to Q, and then, sorry, this one is the resultant RQ. I will move from R to P and then P to Q. RP plus PQ. Both are given. RP is minus 3A minus 12B. And PQ is 4A plus B. The final answer is A minus 11B. Now part B is show that QT, this QT is equal to 3 bracket open, B minus A bracket close. Now part B is we want to find out QT. Now the components may be QP plus PT, but we don't have PT in the previous working. But we have QR. We have in the previous part we have the expression for QR, RQ, and then RT. Part number 2 is RT. We will use this path. We will use the path in which vectors are known. So components are QR plus RT. QR is, we have the expression for RQ. When we will convert this one into QR, we have to put a negative sign with this. That is minus A plus 11b. Now, RT. What is RT? RT is minus 2a minus 8b. We will simplify this one, and this one is minus 3a plus 3b. So the final answer is 3 bracket open b minus a, which is the requirement for part B. Now express QS as simply as possible. QS as simply as possible in terms of A and B. C part is we want to find out the expression for QS. In QS, Q is the tail, S is the head. Stand at the tail, which is Q, and move towards S. QP plus PS. QP plus PS. Now QP is, we have the value for PQ, expression for PQ 4A plus B. The expression for QP is minus 4A minus B. The expression for PS is 5B. The direction is same, so we will not change the sign. Minus 4A plus 4B is equal to 4 into B minus A is the expression for QS. Okay, now part B. In part D, we want to find out QT over QS. QT over QS. We have the expression for QT, which is 3B minus A over, if the expression for QS is 4B minus A. We will cancel out B minus A with B minus A. The answer is 3 over 4. Now, we want to find out the area of triangle PQT. D part, this is D part 1. Now D part 2 is, we want to find out the area of the triangle PQT divided by area of the triangle PQS. PQT is this triangle and PQS is this triangle. This triangle is P, Q and T, and the other triangle is PQS. That is this. These are the two triangles. First of all, we will think that whether these two triangles are similar or not. The triangles are similar when three angles of one triangle are equal to the three angles of other triangles. That is the AAA postulate. And we do not have any information about the angles. The second property through which we can prove that the triangles are similar is the ratio of the corresponding sides is same. Now, in this question, all sides are not given and we cannot find the ratio of the sides of the triangles. Now, these two triangles, we cannot prove that the two triangles are similar. So, the second thing we will think about is we will look for the parallel bases and the heights of the triangles should be same. Now, bases of the two triangles should be parallel. One triangle is PQT black one and the other one is PQS. Now, PQ is the same side of the two triangles. If we will take PQ as the base, then base of both the triangles, bases of both the triangles are parallel. Now we will find out the height of both the triangles. To find out the height, PQ in PQT, PQ is the base, opposite vertex is T. This one is the height of triangle. Now in triangle PQS, the base is PQ. We will extend this base and draw a perpendicular from the opposite vertex S. This one is the height. Bases should be parallel, heights should be same. Now bases are parallel, but the heights are not equal. So we will not consider PQ as the base. We will look for another option. Now QT and QS are also parallel sides of the triangle. QT and QS are also parallel sides of the triangle. Now, if I will consider QS as the base, this one is the height of the triangle from the opposite vertex. And in the triangle PQT, when QT, we will consider QT as the base, we will have to extend this QT and we will draw the perpendicular from P to the base, extended base. This one is the height of the triangle. Now you can see that both the triangles have the same height and the bases are parallel. Now we will use this one. Area of the triangle PQT divided by area of the triangle PQS is equal to half base into height, half base into height, half base into height, half base into height. We will cancel out half with half, age with age. Base of PQT is QT and the base of PQS is QS. Heights are same. We will cancel out the heights. Half has the same value. We will cancel out half and half. Now Q2 over QS we have calculated in D part 1, which is equal to 3 over 4. So the ratio of the area of PQT over PQS is 3 over 4. If the triangles are similar, then the question is very easy, that L1 over L2 whole square. Now we will attempt part 3. In part number 3, area of the triangle PQT over PQR. PQT. PQT. This one is the triangle PQ and T. The other triangle is PQR. PQR. Now we will take PR and PT as the base. PR and PT as the base. If we will take PR as the base, then the height of the triangle is this. From the opposite vertex, this one is the height of the triangle. And if we will take PT as the base, from the opposite vertex Q, first of all we will extend the side PT, and from the opposite vertex the perpendicular to the extended base is the same as the perpendicular of from Q to the side PR. Now bases are parallel, heights are equal. This one is the main concept to find out the ratio of the areas. Area of triangle PQT divided by area of triangle PQR is equal to half into base into height, half into base into height, and this one is equal to, we will cancel out half with half and h with 8. Now the base of the triangle PQT is PT, and base of the triangle PQR is PR. We have the ratio of these two sides, PT and PR. PT is 1 and PR is 3. So the ratio of the area between triangle PQT and PQR is 1 over 3. Now this one is all about finding the components and finding the ratio of the triangles in the question of vectors. It's all about this lesson. Thank you very much. The link of this exercise is given in the description. You will have to attempt all the questions of this exercise, and then you will be able to attempt all the questions in the past papers. Thank you very much.